See, fine student, in this what we are going to continue means we are going to continue about the numericals which we are doing here. Earlier that we started, no, those numericals we are going to discuss here. So what is the numerical it's telling means if the separation between second maxima and fourth minima on same side of central maxima is 0.5 meters. Find the fringe width they're asking. Find the fringe width they're asking here. So what we have to know means here the separation between second maxima and fourth minima they're asking. So if we take here central maxima, this is central maxima, this is a screen which we can take here. So what we'll get somewhere here second maxima will get it here, second maxima. What they're asking next fourth minima somewhere here we'll get it here, fourth minima. This distance we need to calculate here. The distance you need to calculate means what means you have to do this fourth minima minus second maxima. If you calculate you will get the answer, na? So fourth minima, how can you will get fourth minima? So fourth minima can be written as what? Na? Y4 can be written as 2n minus 1, 2 into 4 minus 1 lambda d by 2d. Therefore y4 can be written as what? Na? 2 4 is 8, 8 minus 1 is 7, 7 lambda d by is nothing but fourth minima which we got it here. Now second maxima, second maxima, if you want to get no, y second maximum, second right fringe, n lambda d by d which we are having. Second one, na, y second maxima or second right fringe equal to what we can write it, 2 lambda d by d which will get it here. Now what we are going to do here, so what we are going to subtract this fellow from this fellow, we are going to subtract here. So let me subtract here, what we get it here, 7 by 2 lambda d by 2d d minus 2 lambda d by d. If we take LCM, how much will get it here? 7 by 2 means here will get 6, 2 to the 4, 7 minus 4 will be 3. So 3 lambda d divided by 2d equal to what we got it. In the answer they told like 0.5 meter. 0.5 meter means I can choose like half meter here. Therefore, lambda d by d can be written as what, Nana? So what we can write, these two will go to numerator. 3 by 2 if I send here, no, this side what will happen? 2 by 3. So 2 by 3 into 1 by 2. This fellow will get cancelled. Lambda d by d equal to how much will get, Nana? 1 by 3 meters, you got it. This is nothing but what we got it here. Fringe width we can write here. Or if you substitute this value, no, we'll get like 0.33 meter also, we'll get it here. So listen one second question. Question says that if the separation between second maxima and fourth minima on same side of the central maxima is 0.5 meters, find the fringe width they're asking. So we are having y4, we know 2n minus 1 lambda d by d, 2 into 4th minima. So 2 4 is 8, 8 minus 1 is 7, 7 lambda d by 2d. Second maxima, what we are having, y2 max equals to n lambda d by d. Therefore, y2b equal to 2 lambda d by d, you know. So this separation we need to calculate means this minus this we need to do. That's what we did here. That should be equal to how much they're telling here. That should be equal to 0.5 meters they're telling here. 0.5. So if you observe here, no, 3 by 2 lambda d by d equal to 0.5 meter equal to what we can write? 0.5 can be written as half meter we can write here. Lambda d by d can be written as 2 by 2. I'm sending this 2 here. This will come to 3 denominator. 2 3 by 3 into 2. 2 will get cancelled. Lambda d by d equal to 1 by 3. That's nothing but what we get now. 1 by 3 meter. That's nothing but 0.33 meters, which we can tell here. So in this question, what they're asking is they're asking like this. Let me change the slide. Yes. So the question says like this. What is the question they're asking means this is NCERT model. I'm not taking exact NCERT question. I'm changing another question I'm taking here. The question they're asking like this. Two identical sources emitted waves which produces intensity of k units at a point on the screen, where path difference is lambda. What will be the intensity at a point on the screen at which path difference is lambda by 4, which we are taking here. See, if you observe here, in the question they given relation between path difference and phase difference, we need to find by taking the relation. We know that delta phi equal to what we know? Delta phi equal to 2 pi by lambda into delta x, which we have derived here. So in the question they told in first case, delta phi equal to 2 pi by lambda in terms of next delta x value they given like lambda. So lambda, if I take here, no, lambda will get cancelled. Delta phi equals to how much will get it? 2 pi will get it. Now what we need to check? Imax. What is Imax formula? We know that Imax equal to 4i times the cos square delta phi by 2, which we know here. Delta phi value 2 pi na. Therefore Imax equal to what they're telling here? 4i into cos square 2 pi by 2. This fellow will get cancelled. Cos square pi. Cos pi is nothing but minus 1. Cos square phi is nothing but pi is how much? Minus 1 square. So as a result, what will get it here means Imax equal to what will get na? 4i into minus 1 whole square will get ds. So what will get it here? 4i will get it here. And that 4i value is equal to how much they're telling in the question? K units they're telling. This value 4i equal to k they're telling. Now where we need to find this k value? Wherever path difference is lambda by 4 is there, no, at that place we need to calculate that intensity. So delta phi 2, if you want to discuss here, delta phi 2 equal to 2 pi by lambda into delta x value they told in the question lambda by 4. Lambda 2 1 ja 2 2 ja. Delta phi 2 equal to what we got it is here? Pi by 2 we got it. Therefore Imax formula what we are having earlier? 4i into cos square phi by 2 we are having. Here 4i value got like what? K here. I'm just writing like k here. Therefore Imax equal to k times the cos square phi by 2. Delta phi value how much you got it? Pi by 2. Pi by 2 divided by 2. That's nothing but pi by 4 will get it. Cos square pi by 4. Pi by 4 is nothing but what will get it here? 45 degrees. 45 degrees is nothing but how much? 1 by root 2. Therefore 4 into 1 by root 2 whole square. Square root will get cancelled. Therefore Imax equal to what will get it here? Answer will get like k by 2 will get it. So this is nothing but intensity where path difference is what? Lambda by 4 are they given in the question. Lambda when path difference is nothing but lambda by 4. Intensity mod we got k by 2, which we got it here. So very simple question. NCERT standard question, which is an NCERT in terms of lambda by 3 they given. Same question they given in terms of lambda by 3. I'm just changed like lambda by 4. Already they asked in NEET also once the same question they asked in NEET also. Same model which they asked already asked. That's why you need to practice well. Let me check into next question. In next question, what they're asking is they're asking like this. So what they're asking means in YDSC, the angular width of slit is 0.2 for the sodium light of lambda equal to 5890 angstrom. Sodium light means yellow color light generally. in order to increase the angular width by 10%, the necessary change in lambda is. See, basically we should know that angular width, how to define means angular width can be written as what means fringe width upon capital D. Fringe width, what we know here, lambda d by d upon capital D. This fellow will get cancelled. So lambda by d will get it. That's nothing but what we can write, theta. Therefore, angular width can be written as what we can write it here, lambda by d, which we have to remember in mind. Now in the question they're asking, what they're asking, theta and lambda relation they're asking. Observe here. So theta and lambda is changing now. So theta is directly proportional to what we can write here. Theta is directly proportional to lambda if d is constant. If theta is directly proportional to lambda, no errors. If you write fractional change in error, delta theta by theta equal to delta lambda by lambda, we can write it. Therefore, delta lambda can be written as what here? This lambda will go to numerator, no? Delta theta by theta into lambda, we can write it. Delta theta by theta is how much, na? 10%, no? So what we can write it? 10 by 100 into 5890. 1010 cancel. This 0 will get cancelled. Therefore, delta lambda equal to how much we got it? 589 angstroms, which we got it. This is the necessary change in what? Wavelength. So read the question once again. In YDSC, the angular width of the slit is 0.2 for the sodium light of lambda equals to 5890 angstroms. In order to increase the angular width by 10%, the necessary change in lambda is angular width. How to define? Fringe width upon distance between the slit and screen. So the capital D, small capital D will get cancelled. Lambda by d will remain. That equal to nothing but what we can tell, theta. That is called angular width symbol, Nana. So theta equal to lambda by t. So if d is constant, no, theta is regular to lambda. Errors if you write, no, delta theta by theta can be written delta lambda by lambda. Switch this fellow here. So delta lambda remains as delta theta into lambda divided by theta. Delta lambda equals to 10%, no? 10 by 100. This 0 will get cancelled. This 0 will get cancelled. 589 angstroms remains here. So if you observe here, no, delta lambda equals to 589 angstroms, which we can tell here. That is the answer for this question. Now, next question, what they're asking me, they're asking like this. The slits in YDSC have equal width. Equal width means what we can tell here, equal intensity. So they're asking question like this. The slits in YDSC have equal width and the source is placed symmetrically. Source is placed symmetrically with respect to slits. The intensity at central maximum is I naught. If one of the slit is closed, the intensity at this point will be how much we have to know, Nana. So how to check means, let me check here. We're having one screen here and we're having slits like this. So when you're sending light here, no, it's going like this, it's going like this. Here we're going to face the central maxima here. So central maximum value is what we know basically here, 4i central maximum. 4i will get it. That value equal to how much they're telling in the question, They're telling us I naught. So how much light is passing here? I is passing. How much light is passing here? I is passing here, going and forming like 4i. That 4i value is equal to I naught, they told. So means from here what we can write, I equal to what we can write it? I naught by 4 we can tell. Means what we can tell here means this value how much we got it here? I naught by 4. This value also how much we got it? I naught by 4. In the question what they're telling, the intensity of the central maximum is I naught. If one of the slit is closed, then the intensity of this at this point will be one of the slit is closed. If this slit is closed, no, how much intensity will go is come here? So single slit experiment now only I naught by 4 will get it here. No diffraction pattern, no interference pattern will be observed here. So single slit what will get it here? No interference pattern will come now here. I naught by 4 which will be come here. So how much is answer means I naught by 4 which you can tell here. So let me have a look into next question what they're asking in the question here. They're asking question like this. See, question says like this. The maximum intensity in YDSC the maximum intensity in YDSC is I naught. Distance between the two slits is 5 lambda. Distance between the two slits is 5 lambda means nothing, 5 lambda. That's nothing but small d, where lambda is wavelength of monochromatic light. Light is used in the experiment. What will be the intensity of light in front of one of the slit and the screen at a distance of 10d. See, slit to the screen distance is how much? 10d they told you. So first you have to collect the data carefully. So in the question they told you lambda value they told you in terms of then d value they told you in terms of 5 lambda, and then capital D value they told you in terms of small d they told you. So we need to catch these all things carefully. So what all the data we need to calculate means we have to connect. So in solution, so what we're having here, first thing is wavelength is nothing but how much intensity is I naught, wavelength is how much lambda, small d equal to what we know here 5 lambda they told, and capital D equal to what they told here 10d. 10d means small d value how much we are having, 10 into small d equal to how much we are having in 5 lambda. Therefore capital D equal to what we get 50 lambda, which we got it. So while doing YDSC experiment we got this value, this relation delta x by y equal to what we got it here, small d by capital D, which we know here. Delta x by d, delta x by y, delta x by value, y value is how much they given in the question, 5 lambda by 2. So if you substitute this value here, no, delta x by y value is nothing but 5 lambda by 2, will get it here, is equal to d value 5 lambda divided by capital D value 50 lambda. 5 1 ja, 5 10 ja, lambda will get cancelled, 5 1 ja, 5 2 ja. This 2 also will go to numerator. Delta x equal to how much will get it here, lambda by 4, you got it here. We need to remember delta x value. If you know delta x value, that's easy to calculate delta phi value. From which formula? Delta phi equal to 2 pi by lambda into delta x. Substitute delta x value. Delta phi equals to 2 pi by lambda into delta x. Delta x equal to what we can take here? Lambda by 4. Substitute that lambda 2 1 ja, 2 2 ja, pi by 2. Delta phi equal to pi by 2. And I net can be written as what, Nana? I net can be written as 4i cos square 5 by 2. But in the question they told 4i value is how much that they told here? I they told you. I naught. Therefore, I net equal to I naught into 4i cos square 5 by 2. Cos square 5 by, in the place of 5, what we are going to substitute? Pi by 2 whole divided by 2. That's nothing but pi by 4. Cos square pi by 4, which will get it here. Therefore, I naught into cos square pi by 4 value, how much will get it? Into 1 by 2. Therefore, answer will get like how much will get it means I naught by 2, which will get it here. So, in net intensity at that point, what we got it? I naught by 2, which we got it here. See, in this question, what they're asking means they're asking one question like this here. See, the standard NCERT question. I'm just changing little thing in this. So, how we are writing means here question NCERT standard question. NCERT question. So the question says like this: in YDSC, third bright fringe obtained on the screen with a light of 700 nanometers. What should be the lambda of, means wavelength of source in order to obtain fifth bright fringe at the same point? What we need to change? We need to change the wavelength such that we should get, on the place of third bright, we need to get fifth bright, we need to get. They're asking in the question. See, the question they told, why third bright fringe equal to what they're asking? Why fifth bright fringe we need to change? By changing the what, Nana? Wavelengths. So if you observe here, no, bright fringe formula, what we are having? N lambda d by, na? So N3 lambda 3 d by equal to N5 lambda 5 d by d. So this d will get cancelled. So lambda N3 value much they telling third, na? Third. Lambda 3 value much they told you for third bright fringe, lambda value corresponding how much? Corresponding to 700 nanometers. 700 is equal to fifth bright fringe into lambda for fifth bright fringe. We got it here. So what will happen means here, if we cancel this, no, 14 5 is 70. Okay, 140. 14 3 is 42. 420 nanometers, which we got it, lambda 2 value. This is answer. Similar question is there in NCERT. You people just need to practice here. You need to practice here. This is important question. Third bright fringe equal to fifth bright fringe. We need to get at third, fifth bright fringe. Just by altering the what? Wavelength, we need to get that value there. SDS. In this, we are going to discuss if YDSC performed in liquid, what will happen? We are going to discuss. After that, we are going to solve numericals based on that. So, what we are going to discuss here? If YDSC performed in liquid, first let me discuss if YDSC performed in normal, a general one. That's nothing but air which is performed on that thing. And next one about that, what we are going to discuss, liquid. If YDSC performed in liquid, no, generally. Normal, if I take wavelength value, how much we can take? Lambda means in liquid of refractive index mu, if it is performed, it means wavelength is decreasing by how much? Means lambda by mu is decreasing, which we learned in ray optics. Means we know about the fringe width. We know fringe width is what we know, beta equal to lambda d by d. You know, in the place of lambda, so here lambda dash is how much? Lambda by mu, na? Therefore, here beta dash can be written as what we get it here means lambda d by mu d will get it. It will decrease by mu times at mu d. So if I want to discuss about the angular fringe width, that's nothing but lambda by d, which we can write it, na? Here what we can write it, theta can be written as in the place of lambda, lambda by mu d, which will get it here. If you want to discuss about the y nth bright fringe, you know, what will get it here? n lambda d by small d equal to, so what will get it here? This case will write why nth bright fringe means wavelength decreases by mu times lambda capital D by mu d, which we can write it here. Dark fringe, nth dark fringe, if you want to write it here, what we can write it here? 2n minus 1 lambda d by 2d. So what will get it here? Y nth dark fringe equal to what we can write it here? 2n minus 1 lambda d by 2 mu d, which we can discuss here. So these are all the important set of the formulas which we need to remember for the solving numericals. So nothing will change. Whatever the thing you learned in A, no, so that every value will decrease by mu times in if you perform in the medium, which we need to understand here. These are the important points which we have to remember. See, fine. In this, what they're asking question here means they're going to ask question like this. They're asking question in YDSC, in Young's double slit experiment, separation between slits is 1 millimeter and screen is located at a distance 1 meter from slits. Light of wavelength light of wavelength light of wavelength 600 nanometers is used. Now whole YDSC setup immersed in a liquid of mu equal to 4 by 3. Mu equal to 4 by 3 means in water they immersed. Find out change in position of fourth maxima before and after immersed in the liquid. After immersed in the liquid. So what we need to discuss means here. So first we need to discuss about the bright fringe, fourth bright fringe. Why fourth bright fringe is nothing but what will get it? 4 lambda d by d, because n lambda d by d, na? 4 lambda d by d. Why fourth bright fringe? After immersing in water, what we can get it? 4 lambda d by mu d. It will decrease by mu, I told you. These both difference we need to calculate. Why fourth bright fringe minus y dash, let me take this is y dash fourth bright fringe equal to what we can write it? 4 lambda d by d. 4 lambda d by d, if I take common here 1 by mu remains. So I can write like this value. 4 lambda d by d into 1 minus 1 by mu. Therefore, what we can write it here? This can be written as 4 lambda d by d divided by 1 minus 1 by mu. Mu value in the question they told 4 by 3 here. So that value we are going to substitute here. 4 by 3, 3 will come to numerator. So 4 lambda d divided by d into, if I take LCM now, 4 minus 3 is nothing but 1. 1 by 4. This 4 will get cancelled. How much will get it here? So 4 will get cancelled. Lambda d by d will get it here. So lambda d by d, lambda value they given in the question 600 nanometers. Capital D value they given, small d value they given. If you substitute those all values, no. So let me check here. That equal to what we can write here? That equal to 600 into 10 raised to minus 9 nanometers means into 1 meter divided by 1 milliliter means 10 raised to minus 3. 10 raised to minus 3, 10 raised to minus 9 will go cancel, minus 6 will get it. Here 2 zeros, here 2 zeros will get cancelled. 10 raised to minus 4 will get it. Therefore, How much is shift means what will get it? 6 into 10 raised to minus 4 meters, which we can tell here in shift. Otherwise, what we can write it here? So if I multiply with divide with 10, multiply with 10, what will happen here? We can write like 0.6 into 10 raised to, otherwise we can write, yes, that's what, 0.6 into 10 raised to minus 3, we can write it means 0.6 millimeter shift, which we can tell in this question here. This is a shift in what we can tell here? Shift in fourth bright fringe, which we can tell here. See, next question also, which question means this is a standard NCERT based question, which we are going to discuss in this question also. So in this question, what they're asking is they're asking question like this. Standard NCERT question. What is the question they're asking means? If YDSC performed, if YDSC, Young's double slit experiment, performed by bichromatic light of violet 400 nanometers and blue 500 nanometers. Two colors. If it is performing with two colors, they're telling. If distance between the slits is 1 millimeter and distance between the slits and screen is 1 meter, they told these values. Then what they're asking means find out when does violet color overlap with blue color first time, and find out position. Where does they both meet first time? They won't ask you position generally. They'll ask you when does they meet you. So how to check this means this already we discussed one question, similar question only. So violet light and yellow light is what they are telling here, overlapping means they are forming at same place, means distance of violet equal to distance of blue we can take here, means NV lambda V d by d equal to what we can get it, NB lambda B d by d. Bright fringe value we written here. Lambda d by d will get cancelled. NV by NB can be written as what here? Lambda B by lambda V. So NV by NB can be written as lambda B by lambda V value. How much we got it here? 500 by 400. 500 nm by 400 nm. Nanometers will get cancelled. 00 will get cancelled. 5 by 4. That 5 by 4 indicates that we have to understand that fifth maxima of violet 5 by 4. Fifth maxima of violet and fourth maxima of blue will go inside enough first time. Then what they're asking position, now let me take V5 because fifth maxima they're telling we got it now here. So V5 we calculate now here, 5 lambda V d by d we can write it. Therefore y V5 equal to what we can write it, 5 into 400 into meter 1 into and delta this 400 nanometers range, 10 raised to minus 9 divided by d is 1 millimeter, 10 raised to minus 3, minus 6 will get it. So 5 4 is 20. So these two zeros gone, minus 4. Therefore y V5 equal to what we can get it, 20 into 10 raised to minus 4 meters. This zero got cancelled, means y violet can be written as 2 millimeters, which we can write it. 10 raised to minus 3 we can write like millimeters. At this position they both will form first one. For example, if they tell you where does second time overlap means, first time overlap at which position means YV by YB equal to what we got it, 5 by 4 we got it now. This is first time they are meeting, I told you. So fifth one of violet and fourth one of blue is meet first time. If they ask you second time, no, you just multiply with 2 now. If you multiply with 2, no, 5 2 is 10, 4 2 is 8 will get it here. So 10th of violet color, 8th of blue color will match. Third time if they ask you, 5 3 you need to multiply 15 by 4 3 12, fifth bright fringe of violet color, 12th bright fringe of blue color will meet third time. This is for second time. Generally they won't ask you in normal questions, so they will ask you in JEE questions only, JEE type of questions only, where they will ask you, meet you first time, second time, third time. Otherwise for NEET, CET, CBSE boards and all, MC questions what they can ask you, first time 5 by 4, second time 10 by 8, third time 15 by 12. Position if they want to wait, no, so 2 millimeters, which we got it here. This is the answer for this question, which we can discuss here. See, in this question, what they're asking means they're asking question like this, Nana. So what they're asking means light of wavelength 400 nanometers and 500 nanometers are used successively on YDSE, in which small d equal to 1 millimeter, capital D equal to 1 meter. Find the shifting of position of first maxima. They're asking first maxima. So we know that first maxima, how to discuss here means first maxima value, what we can write here. So with lambda 1, first max, how can you write it? Y1 equal to 1 lambda 1 d by d, which we can write it. With lambda 2, first maxima, if you want to calculate, no, y dash can be written as lambda 2, 1 lambda 2 d by d, we can write it here. Chain they want means delta y. Delta y can be written as what? Y dash minus y1, we can write it here. Lambda y1 minus y2 or y2 minus y1 we can do. So just check which one is more in the question. 400, 500, y dash only more. So what we can check here means we can check like small d by d. So if you take common these two both, now here what we can get it here, capital D by small d can be written as what we can write it means lambda 2 minus lambda 1. Lambda 2 minus lambda 1. 500 minus 400 is nothing but how much? 500 minus 400 is nothing but 100 will get, na. Therefore, if you write no delta y value, if you observe here, no, 100 into 10 raised to minus 3, capital D value 1 meter, small d value 10 minus 3, 10 raised to minus 9, nana, nanometers means minus 3 minus 6 will get cancelled. Therefore, delta y equal to 10 raised to minus 6 means 10 raised to minus 4 you will get it. Otherwise, we can write like 0.1 millimeter, which you can write it. This is a shift of first bright fringe, which we can tell here. Fine, dears, this is for today's class. Please revise once again carefully to understand better. Thank you, dears.